Hello, time for an updated lecture video. It's been a minute. This one I desperately had to update because the one I had was from 2020 and a lot of stuff's changed. A lot of it's the same, but it seemed weird to just update the very ending. So here we go. This is to cover about power and global warming and whatnot. I'm going to kind of just like through a chunk of it because I don't need to spend a buttload of time on each slide. You can read, the PowerPoint is available online on Brightspace, but I wanted to give you some highlights. There we go. How I always start off. When I have actual people for this, so like it's an in-class, like an in-person class, or when I'm teaching for one of my other jobs, we do a 2 hour long Zoom session for our classes. When I do that, I actually get feedback for this. Your class, we don't have that. And so kind of have to stick with this. I'm sorry. The first thing I always ask is whether or not we need power, not do we want power or do we like power? And I'm not talking about people who are like legit hooked up to machines, like on life support. I'm talking you, the person in this class. Do you actually need power, like to survive? The answer is no. You have probably had times where the electricity went out. You did not die. So it really is something we just enjoy. Um, there's a lot of things that would be different if we didn't have power. I'm clearly using power. I flip and teach online for 3 of my 4 jobs. I teach online. And right now I am sitting here in my sunroom and I've got a heater running because it's really flipping cold. Clearly I like my power too, my energy. We have various options on how to get our energy. And the big important thing to realize is when we are talking about resources, we're talking about how we are getting our electricity and our energy. I know it seems weird for me to specify this, but in the past, I've had quite a few students who didn't quite understand the difference. So we're going to cover that. So right here, this is one. We've got tar sand oil, and there's a lot of it. And it's just, again, it's another way to get more oil because we use a lot of oil. That's pretty much it. There's a bunch of cons to get the tar sands oil. And the main ones that I'm going to point out is it uses a lot of water in order to get it, and that water cannot be reclaimed. So it has on here that the water required is 3 to 1, so 3 parts water for 1 point oil. And that's extremely wasteful. It also pollutes a lot of areas while you're doing that. And for me, one of the big ones is the fact that it is a lot of habitat destruction. And this is on ancestral lands. And so these are going to be indigenous people who have already been historically everything taken from them. And it's just another case of people coming in again and saying, hey, we can give you a job. You work on this, let's strip up your land so we can get more resources. I have an issue with that. Coal. We are a coal nation for sure. We have done so much coal. And you're going to notice in your discussion, you're actually looking at stuff about coal this week. There's a lot of coal. It's still a non-renewable resource, but there's a lot of coal. It's a mature industry. We've done it for ages. They know what they're doing to get it. The issue is it's really not good. It's not renewable. It pollutes. It actually has high levels of radiation. The coal plant itself has more radiation than a nuclear plant. Bet you didn't know that one. Um, there is no way to have clean coal. Clean coal is not carbon free. All it means is if you hear the thing about clean coal or the carbon scrubbers, it's just trying to catch more of it before it goes out into the air, but it's still producing it and you still have to figure out what to do with it. It's also a very dangerous job. It undermines, and when you read the article in the discussion today, you'll see part of what it's talking about. Natural gas. Natural gas is cleaner burning. It's less carbon dioxide than both coal and oil. And it's been getting used a lot more and more and more. And you can make a lot of stuff with it. It's not very good. Even though it's a lot lower in carbon dioxide, it's still extremely high in methane, which is a greenhouse gas. And we'll talk about the importance of that after we finish talking about the different resources. Highly flammable. They have to add the smell to it in order to warn people in case there's a gas leak. But the big thing is connected here to fracking. Fracking is where they are fracturing the earth with water in order to reach more of the natural gas areas. And this has been causing a lot of issues. And there is loads of evidence of increase in earthquake activities near areas where they have done fracking. It's pretty bad. Biomass. Pros. This is a renewable fuel. So this is basically just taking stuff and using it, like growing corn and using it to produce ethanol, that kind of thing. So it can take waste, turn it into energy. There you go. You can actually take like biological wastes and burn it in order to use it. But there's still cons. Cons are anytime you're burning it, it's still going to be releasing carbon into the air. It's going to require you to grow things. It's possible that in order to get more for fuel, that less will be used for food. This started happening back in, I want to say it was like 2006, 2007, somewhere in that time period, when, if you remember, we started getting more and more ethanol out there. And so a lot of areas were growing only corn in order to make this. And that was having us have fewer fields of other kinds of agriculture. And that's not really helpful. Nuclear energy. You will see a lot of people touting the pros of nuclear energy because after you have built the place, it's supposed to provide you with energy at a relatively low cost. Notice I say after you build it because it costs a buttload of money to grow it. It's lower in the greenhouse gases that it emits, and so it seems to be a cleaner energy. There's a lot of cons, like a lot. It costs a massive amount of money to build to begin with. It's still a non-renewable resource because it requires uranium, which is a limited source. So nuclear energy is not renewable. It takes a while to build it, becomes a big target because as soon as it goes down, you kill everything in the area. I mean, that's pretty much it. We have no idea what to do with the waste. Once you turn on the nuclear reactor, it's on forever because we don't know how to officially turn it off. It can stop being used to produce energy, but it's going to keep doing its thing. So we have to keep it cool. And most of the way these are kept cool tends to be with like, not all of them, because not all of them are near an ocean, but the ones that are coastal tend to have the ocean water going through it in order to help keep it cool, but then that's slowly leaching some of the radiation into the ocean, which then goes into the ocean and then continues along. The idea when they first started doing nuclear energy was, wow, look at this. It makes so much energy for so little. This is phenomenal. And then someone's like, hey, but what about this radioactive waste? It's okay. Scientists are smart. They're going to figure out what to do with our waste product. No one ever figured out what to do with the waste product. And the waste lasts hundreds of thousands of years. What is currently happening is it's like getting stuffed under mountains or finding a country that is rather poor and then you pay them to take it. It's pretty bad. It's pretty bad. So nuclear energy, not really beneficial to the world, the planet, and the environment. Tidal powers. This is totally renewable, does not require any fuel, emission free, blah, blah, blah. There are still cons for this. They cost a lot. There's only very specific locations you can do it, and it mucks up the entire habitat in that area. So anything that was living in there, you just destroy their homes. So it completely impacts the entire ecosystem. Wind power, totally clean, very easy to do. Once you have that sucker up, there's not a whole lot you have to do other than collect the energy. There are some cons. The wind is not always blowing. And so obviously it's not going to be going round and round if there's no wind. Building it costs. If you have to replace parts, that's a big thing. It used to be built in like migratory patterns, and so now they've actually gotten better about that, and so they try not to put it in areas where birds are going to be flying straight through. Some people think they're ugly, and yeah, that's pretty much it. I mean, you're going to have battery backup for it. If you have an entire wind farm, like you'll see in some areas of the US, then they route that to the actual power plant. So then that can go out to everybody. So you don't have to worry as much about the whole battery part. But they're actually super helpful. But I'm showing you pros and cons of everything. Solar photovoltaics, solar panels. That's pretty much it. There's no moving parts. It's even better than the whole wind turbine because the wind turbine has moving parts. So you're going to have to service it randomly. Solar panels, put them up there, leave it. That's it. The sun is going to rise. And whenever the sun finally stops being here, we're not going to be here anyway. So there you go. You have solar panels. You can use more of your electricity during the day while the sun is beating on you. And that's normally when you're going to want to do more. I have 4 solar panels and I have them attached to my, I lost the word, the thing for my air conditioning, the big old box, compressor. Anyway, I have that hooked up to my solar panels because when the sun is the hottest, the brightest, that's probably when I'm going to need the most air conditioning, you know? They are very easy to use. You just pop them up and go. There are cons. Obviously, the sun is not shining at night. If you live somewhere where half the year is going to be dark, clearly it's not going to be beneficial for that half the year. You do need to convert it some. So it's not hard to have that part done, but you have to do that. The stuff used to make the solar panels, not the best on the planet. So reusing as much as you can is very helpful. They're not as fragile as they used to be. The biggest issue, in my personal opinion, is the last one here, where we keep learning more and more about the photovoltaics and making better solar panels that you might spend money to get a whole setup and then they might come out with a better one quickly. Kind of like you finally save up, get the laptop you've always wanted, and then like 2 months later, a whole brand new version comes out and you're like, same kind of thing. Now, what does this mean? I told you about some renewable and some non-renewable resources. I showed you pros and cons of all of them. The reason I make sure to do pros and cons of all of them is because you have to look at all of it. You can't just say, well, I think we need XYZ and ignore everything else. There are benefits to every kind of the energy, and there are cons to every one of them. You just have to balance out which is more important to you. And hopefully you include the environment in that, because if we don't have a healthy environment, we're dead. And that's part of what drives me nuts when people don't seem to put those two together. If we don't have air to breathe, we're dead. And if we keep having everything get hotter and hotter and hotter every summer, we're not going to survive. I mean, that's a fact. You can only keep jacking up your electricity to keep you from burning for so long until you blow out the power plant and nobody has power. Um, that doesn't even get us into what's going on with the animals and the plants and the migration patterns and diseases, but that's another day. I actually have a different PowerPoint for that. But we're going to talk about greenhouse gases and what all this means. So anytime you see GHG, that means a greenhouse gas. These are gases that can trap the heat in the atmosphere. I was trying to remember if I have something that has a picture about greenhouses to talk about greenhouses. I'm going to talk about the greenhouse gases, and then if I don't get to the slide that's in my head, then I will catch you up. So there are various greenhouse gases. Most people know about the carbon dioxide. This is what is coming out into the air every time you burn anything. If you're using oil, natural gas, coal, if I go out into my backyard and chop down a tree and burn it, that's releasing the extra carbon into the air. So carbon dioxide is constantly being released into the air. Every time we exhale, we're also releasing carbon dioxide. So what happens is the plants, our ocean does it too, our coral reefs do it, but plants take in the carbon dioxide through photosynthesis. They then make their own food, their glucose, and then they let off oxygen. That's why us and plants get along so great, because we are giving them what they breathe, they give us what we breathe. But if there's too much out there, they can't pick it up anymore, and then it starts to do its thing. Methane. This is also emitted during the production and transport of coal, natural gas, and oil. You also get methane from a lot of livestock and things that are dead, things that are rotting. So cattle are one of the biggest ones. Every time they're chewing their cud, they have the four stomachs, they do that and they pop it up. It's like a little burp. And then they chew again, goes down to the next one, and it's doing this whole thing. That's releasing a little bit of methane. But then also out the other end too. So the more cattle we have on the planet, the more methane. The more cattle we're raising for food, the more plant material we tend to chop down to make more space for more cattle. So then we're removing stuff that's taking in the carbon dioxide while we're adding more methane into the air. And fun fact, the amount of food and water used to raise one cow to adulthood so you can slaughter it for food would actually feed more people than the one cow would. So if you're of the mind that, well, we need the space and the cows to feed people, please know that you're feeding less people by raising the one cow. The math doesn't math. We'll just put it that way. Nitrous oxide, yeah, laughing gas. That's what this is. This is emitted a bunch during the agriculture and industrial activities, and also combustion, fossil fuels and solid waste. Oh, I forgot to say that on the last one. Here where it said the solid waste landfills, also goes here with the solid waste. Anytime you throw something away in your garbage and then they just cart it away in the garbage truck, they then take it to a landfill where they just dump it. We've got mountains of nothing but garbage. So if you're like taking a road trip, I live in the Atlanta area. I used to be in Valdosta, so I've done that stretch a lot. There are areas you'll just see all these birds circling, and you'll see what looks like a weird mountain. That's garbage. As the garbage rots, it's letting off methane and nitrous oxide and stuff like that. So our landfills are adding to the greenhouse gases. So just throwing a lot of junk away is making things worse. Then we have our fluorinated gases. Not going to read all these names. You are more than welcome, excuse me, to read these. These tend to come out in smaller amounts, but they are very, very potent greenhouse gases. They are the high global warming potential gases. Some of these, I think I have it on the next one. Yeah. Some of these are what's keeping your car cool. That's the example I tend to use the most. Because if you have a car that in the summertime, you're like, oh man, it's just not really working that well, and you buy a can of Freon and pump that into your car, that's part of the problem. That is a closed system for your car. You should never be adding Freon. If you're adding Freon, it means you have a leak and you're just leaking it into the atmosphere nonstop. How do I know what I'm talking about? If you watched my intro, you'll remember I used to be a diesel mechanic. I'm actually AC certified. I've got my little card and everything. So I used to fix these systems. I know how the air conditioning system works. So you should never be adding Freon. If you are, there's a leak, you need to go get it fixed, because every time you're pumping more crap in there, you're adding more to the atmosphere. You also have to be careful with the disposal of things like refrigerators and anything that has this in here. So there you go. More stuff. Most of this is going to be for different industry stuff that we're producing, we're just making. This stuff is popped out everywhere. Every time you upgrade your technology, yes, it's helpful to have upgraded technology, but that's not coming from nowhere. And getting rid of your used product, whether it's an old laptop, an old smartwatch, or even used batteries, these are adding this stuff into our atmosphere. I got this one just recently. I can't find one for 2024, but the one I used to have was 2011. So, hey, I've gotten there. These are the total US emissions. I used to show world emissions. This is just the US emissions. So, just the total US emissions in 2022. We had 6,343 million metric tons of carbon dioxide equivalent. And this is excluding the land sector. So this is not counting like farms and stuff. This is a lot of greenhouse gases. Most of our stuff is carbon dioxide. That is why you will hear so much push about reducing your carbon dioxide, because dude, over 3/4 of what we're kicking in to the atmosphere in the US is carbon dioxide, and most of it has to do with oil usage. All right, global warming. So we're about to talk about global warming. And yeah, I know I'm going back and forth because I'm trying to see what's coming up. So right here, greenhouse effect. This isn't exactly the one I had in my head, but I'm going to use this to talk to you about it. What the greenhouse effect is first you have to know what a greenhouse is. And I have discovered a lot of people seem to not understand that, and that's where the misunderstanding comes into play. A greenhouse, also called a hothouse, is it's a unit like a building that's put up there, and you've got this film on it that allows the sun to go inside, but it traps it so it doesn't come back out. This is how a lot of places, a lot of people will grow fruits and vegetables year round. So if you ever had a hothouse tomato, it means it was grown in a greenhouse. So like I think it's like 43 degrees outside right now. If I had a greenhouse, it could still be in the 70s in that greenhouse, because the sunlight goes in and it gets stuck in there. So we call this the greenhouse effect here on our planet, because we have these gases that are floating up there, covering all around our biosphere, and it's allowing the sun's radiation and the beams and everything to come in, but it's not letting it back out. So it's trapping more heat in our atmosphere than should be. That's why oh my gosh, we need to quit kicking so much greenhouse gas in the air, because we need some of that to get back out. The reflectivity, this is how much energy something can reflect. I am sure you have noticed in the summertime, if you're barefoot, if you are walking around in the summer with no shoes, you step on blacktop, it burns your feet. You immediately try to run over to something that's white, preferably to actual grass and dirt. But if you can't get to that, you'll find yourself trying to get to the white sidewalk, or you'll start trying to walk on the painted line, anything to get your feet off that black. because the black absorbs the heat. The white helps reflect it. This is why in a lot of areas where they're trying to make it better, they're actually painting their roofs white. As our ice caps are melting and we're losing more snow coverage, there are people out there trying to spray paint the stuff white to try to make it stop absorbing so much heat. So this is where we are. So what's the big deal? A lot of people like to use the bathtub as an analogy, because if you are putting more carbon into the atmosphere than can pull it out, it's going to overflow. I like to use a shower, like, the shower tub combo. Clearly, I have long hair. Both my kids have long hair. So we are a long hair household. Anyone with long hair knows hair is going to go down the drain. So you're going to be fine. You're like taking your shower, everything's fine, water's going down. But then over a period of a few weeks, a month, that water starts creeping up and it's like touching half your foot. If this keeps happening and you don't take care of the problem in the drain, that water keeps getting higher. Suddenly you're in like ankle deep water while you're trying to take a flipping shower. It's very annoying. Eventually, you have to go in there with the messed up coat hanger or a snake or whatever and pull out the clump of hair that's clogged the drain, because it's imperative that your water that's coming out or coming into the shower is equal or less than the water leaving the tub. That is the same concept here. The other example I like to use, because I've had people say, well, I'm just giving the plants more to eat. Most people have heard of Cici's Pizza. You go to Cici's Pizza, it's all you can eat pizza buffet. They just keep on making pizza. Can you go in there, sit down, and keep eating the pizza? They keep making more. Can you eat every single pizza they make? Not sharing with anybody else anymore. You just have to keep on eating it as they make it. No, eventually you can't take in anymore. That's what happens. We are doing so much out in the atmosphere, the plants can't take it all in. So then that leaves the extra out there. So while we're chopping down plants, removing trees, destroying entire areas, at the same time as kicking more carbon dioxide into the air, we've got this massive imbalance, and that's where we currently are. This is here because anytime you read anything about climate change and it talks about the rising of our temperature, one, they always do it in Celsius because most of the planet uses Celsius instead of Fahrenheit. And people are like, oh, it's just a tiny percent. So I love XKCD. I use this to point out just how much a tiny percent might actually be. But we're going to scooch on over here. So here's the main reason I had updated the PowerPoint was for these articles. I like to give you current news. That's why throughout the term, you're going to be getting different current news articles in your discussions. So here you go. I'm not going to read them all. I'm just going to show you these. So we have this one where Americans have been moving into disaster-prone areas. This is from September of 2024. And anywhere that you see the shading, this is the high risk of natural disaster and extreme heat. We're there. And do we know what just happened right over here? Follow all those wildfires that LA just had. It's there. So this article, I believe, is in there with your stuff in the folder of the current articles. So for 2 decades, they've also been some of the most popular places to move as Americans have flocked to the South and West. So anywhere that you see this color is where people have moved in. We're getting more and more people moving into the area that were high risk. Now we have where people are moving out. No joke, people are trying to book it out of LA. It's not a healthy place. There you go. And then this is just showing you the issues of what's happening. So like Florida gained millions of new residents in 23 years, but their hurricanes are getting worse. I was skimming to see if I could see Georgia here real quick. Okay, there we go. Carolina and Florida, more people in the hurricane's paths. So yeah, of course we have more people dying because our hurricanes are getting worse and more people are living there. So this is a lot of good info to show you the stuff that's happening. And again, I have this in your thing. Now, the hurricanes. Have to look at the hurricanes. This one, end of September. So this is before we got the last two hurricanes. This was just the Hurricane Helene. September 26th. Huge. They've been getting bigger and bigger and bigger and bigger. 420 miles wide for this one. Who would have thought we would have a hurricane that would flood a mountain area in North Carolina that's nowhere near the coast? And since most of you are in South Georgia, think of what Helene did to you and Milton. I know Valdosta got decimated. They're not on the coast. Hurricanes are not supposed to hit that far in. This is due to our climate change, the global warming, making everything hotter, is mucking about with all of these systems. And so yeah, this article is showing you that. Most people have always talked about Hurricane Katrina. So let's go find that one. It's down here. Where is it? Did I miss it? There we go. Hurricane Katrina was 403 miles. Okay, 403. Helene was bigger than Hurricane Katrina, and Hurricane Katrina is what most people measure hurricanes by. So this is not a good thing. This is just going to keep on happening and happening and happening and happening. And look, Irma was the first time Atlanta got a tropical storm because we're not even in the tropics. We should not have had it. And then this one, that 2023 had been listed as the hottest year since record keeping began. And then 2024 beat 2023. Chances are 2025 is probably going to beat 2024. So these are huge, huge things. These are various websites where I got the information from in case you are interested. And finishing out like this because I don't want to have just that slide sitting there. This is a big deal. And a lot of people like to try to dismiss the fact that things are happening, that we are mucking up our atmosphere, our planet, our environment, our climate. It is a fact that we have been messing it up. It is a fact that our temperatures are changing. Where a lot of people seem to get lost is when they hear the phrase global warming and then it's cold, they're like, how's that for global warming? That is a very uneducated comment. It works like a pendulum. When we are having our hottest summer, the other side of the planet tends to be having their coldest winter. Please note, summertime of 2024, our hottest on record. How many of you got snow so far this winter that you normally don't get? That is evidence of global warming. We have mucked it up. It is too late to stop it. We are now trying to curb it, to try to do less damage so we can try to repair some. This is part of why I get all fired up on this. I love this planet. I cannot tell you how much I love this planet. I love nature. I love animals. I love plants. I am a tree hugger. I love to be in the middle of nature. I have children. I want to have grandchildren. I want those grandchildren to be able to breathe air I want those grandchildren to know what a tree looks like. I want great grandchildren who can still live on this planet. And the rate we're going, I don't know how many more generations we're going to have where humanity can legit survive. If you think none of this is real, please try to read the articles that are provided, read your textbook, do some research, Google on your own, look up how the temperature has been changing, look up the air quality, look up the rate of asthma, look up the rate of skin cancer. Look at how it's been changing over the past few decades, how it is like legit skyrocketing. It is connected. And the only way any of this is going to change is for people to start caring about something other than a bank account. Because when it comes down to it, you can't breathe money. So even Elon Musk eventually will have to realize he needs air. And I'm only using him as an example because he's the richest person on the planet. If you want to be alive, you have to take care of the planet. That's pretty much it. If you don't care about anybody past your lifespan, keep on keeping on. That's fine. But don't say that you care about humanity or people or the planet or animals. Don't pretend you care about anything if you're not trying to make a healthier place to live. That's pretty much what it boils down to. So hopefully at least a couple of you made it through this whole thing. And yeah, that's it. Peace.